think I turned in a 300-point project.
I turned in a 400-point.
All right, looking at number 25. 25 gives you two things. It gives you vertices at 0 and plus or minus 5. And then it says the ellipse passes through the point 4, 2, and it wants you to find the standard form of the equation. So just by looking at the vertices, how can you tell the direction that it goes? Chelsea?
It's vertical because the y changes.
Yeah, so whatever term is changing is going to be the direction that the ellipse would face, whether it goes up or down, left or right. So since the y is changing, this is a vertical graph. When it's vertical, our larger number should be attached to the y. So if you want to plot the points, plot the points. Make a little picture if you're not sure. But number 25, because it's plus or minus 5 in the y value, that makes this a vertical graph. So I know that the bigger number has to go underneath the y term. What else do we know just by looking at those vertices? So we know it's vertical. Virginia?
A is 5.
Yeah, A is 5 because, Virginia, the center is?
The center is the origin.
Yeah, the center is in the middle of these. And in the middle of 0, 5, and 0, negative 5 is 0, 0. So our center is at 0, 0. The distance from the center to one vertex is A, which is 5, because that distance there is 5. So vertical, A squared must be going underneath the y, so that's 25. It's just a y squared because the center is 0. It's also just an x squared because the center is 0. But you don't know b, and you can't say anything about b until you find b. And the 4 is not part of b, that's just a point on the graph that it's passing. So this b squared is what we need to solve for. If you have a point that the graph passes through, how does that point help you come up with an equation? Brandon? Oh, well, what do you do with the point if you have a point? What letters does the point represent?
A, B, or C.
A point.
X and Y.
X and Y. So the point represents x and y. So x squared is 16. Y squared, well, y was 4, so that's going to be, or y is 2, so that should be 4. So now we have 16 over b squared plus 4 25ths equals 1. The goal is to find b squared. So to solve for b squared, what would you do, Chelsea?
Subtract 4 25ths.
Yeah, take 4 25ths to the other side, trying to get the term that contains the b squared by itself. So 1 minus 4 25ths is? 21 25ths. And then to solve for b, you could cross multiply, because that's how you can get one value equal to the other to get the b by itself. Just cross multiply. So 16 times 25, 21 times b squared. If you have 16 quarters, how much do you have? Chelsea? $4. So 16 times 25 is $4. And then get b squared by itself. So divide by 21. So that's 400 divided by 21, which is a really odd value to have for b. I mean, yeah, they're fractions, but the fractions we work with are a little smaller. Yeah, well, and the 400 is a perfect square, but not the 21. So like, no, 400 isn't a perfect square either. No. Yeah, 20 times 20, 400. Yeah, it's a perfect square. Yeah. But the 21 definitely is not. But luckily, we don't need to graph it, so it's not too horrible. We're just plugging it back into the equation. So x squared with the smaller value, the 421st. Y squared had the 25 because it was vertical and the distance to A was 5. And then it's equal to 1 for standard form. Questions with 25? Are there other questions before I go back and we'll look at the warm-up? So just looking at the warm-up problem, we have an ellipse, we want it in standard form. Vertices are at 4, 3, and 4, 9. So without graphing it, just looking at the value that changes, that tells you the direction. Feel free to graph. It's easier to see visually if you make yourself a little picture. But this is vertical because the y is changing. But we can graph it as well. So at 4, 9, we have one vertex. And at 4, 3, we have the other. And then it says we have a foci, one of them, at 4, 8. So we would have another one down here at 4, 4. So if you have one at 4, 8, you have to have another one the same distance from the other vertex. So Brandon, what can we do with this information to get an equation?
Well, the center would be 4, 6, because it's halfway between both foci and halfway between both vertices.
So the center really is the center. It's the middle of everything. So he said the center is at 4, 6. And then you know A is?
6.
What's the distance from the center to the vertex? 3. So the major axis, the whole thing is 6. But the distance for A is the center to one vertex. So that would be 3. We know C is the distance from the center to one foci, and that's 2. So C is from the center to one focus. The A is the center to one vertex. Doubling it, then I get the whole distance, the vertical distance of the ellipse. Eris, what else can we do to find an equation?
Do 4 equals 9 minus b squared.
Yeah. So 4 is equal to 9 minus b squared. So b squared is 9. And then I have all the information. Just plug it in so that we have a standard form. So center is a 4 for h. We said this is vertical, so the smaller number is 5. We have a 6 for k. That gets the 9. And then it's 1. Questions? So I have a little summary review before we move on to hyperbolas of just the parabola and the ellipse. I didn't include the circle in there. I thought the circle was the most straightforward because it has a center and you're moving equidistance from the center. So I don't have that included on there, but that's the x minus a squared plus y minus k squared equals r squared. That's the one that's equal to a number. We're going to just briefly go through the equations of the parabola. That seems to be the one that people forgot about because we've just been working with the ellipse. Tomorrow and Wednesday we'll go over hyperbolas. Friday we have a conics test, and it'll be on the 4 different conics. So Wednesday, besides kind of finishing up the hyperbolas, we'll look to see, like, just by looking at the expanded form of the equation, how can you tell what shape you have just by using the numbers in the expanded form. And then Friday we'll kind of do a review of all of the conics. So this front cover here has some formulas on it that you can kind of start to use. Hopefully by Friday you'll have them memorized.
I thought conics was going to
You
be
okay there?
You thought conics was going to be what?
a little bit longer.
Oh, well, I mean, we have the other, there's still another part of the chapter. The other part of the chapter,
Longer is sort of.
it's about the same. It's parametrics. So, still looking at other types of equations to work with, but parametrics takes into account a third variable, how time affects the horizontal and vertical variables. So we'll start kind of pulling that into different graphs. We'll be looking at different graphs. Virginia, question? I do. I'll get to you in a little while. All right, so just looking at the parabola information. So I don't want a definition on here. I want, like, the form. What does it look like? What's the equation? So underneath parabola, the vertex is hk. Everything is hk. The vertex, the center. Parabola is the only one that has one vertex. All the others have centers. That's hk. And then we have the vertical versus the horizontal parabola. So remember, the parabola is the one that only has one square term. So it's the conic with one square term because it's the only conic that doesn't really have two parts to it that are either enclosed because they're connecting, or our hyperbolas are going to have two parts, but they're going to be going in opposite directions. So if it's a vertical parabola, what's our squared term? Brandon?
X.
X. That's the one that you always grab, x squared. X squared makes it go up, makes it go down. So the x squared is with the h. X and h are always together. There's the equal sign. What's on the other side of the equal sign, Brandon?
4a times y minus k.
Yeah, and instead of a, it's a p.
4b.
Yeah, and then y minus k. The p is the distance it takes you to go from the vertex to the focus, which is the next term right underneath. If it's a vertical graph, the y value is the part that's being added with p. So y is k plus p. Because the distance from the vertex to go up to the focus is a distance of p units. And then the other part of a parabola is the directrix. That's y, because everything is y, moving up and down. And instead of adding p, we're subtracting it because it's in the other direction. The vertex should be in the middle. So if you go up to get to the focus, you go down to get to the directrix. Remember, the directrix was that line. And then you need to get 2 points on either side of the focus to know how wide the parabola is. Don't just randomly draw the width. You need to find 2 other points to get. So the horizontal form would mean that the other term is squared. So now y is on the left, still with k. Y and k are always together in every single conic. 4p x minus h would be on the right. So horizontally means x is changing, so looking at the focus, x is now increased with p, or the x value is being decreased by p. So when you look at the hyperbola, the difference between the horizontal versus the vertical hyperbola is the location of the larger value, and that's a. So a squared is with x, it's horizontal. A squared is with y, it's vertical, because that's the larger value pulling it more up and down. So you have the remaining 20 minutes of the period. Inside the packet would be the 8 problems that you're doing, and I can't remember if I sent them through Remind or not. I know I had intentions of sending them through Remind. Does anybody remember? I did. Oh, good. So yes, I sent the answers through Remind this morning, so you can check those standard equations. If you would like graph paper, feel free to grab some. Oh, I need to go make more. I'll go make more. Chelsea's in charge.
Oh, okay. That's so fun.
I'll go make more copies of